Hi, and welcome to Mplus Workshop 2. We're going through some of the final steps in Demo 4, and we're going to be talking about a couple of the commands, the plot command and the save data command. So in this, we've already run a couple of things. One of the things that we've run from Demo 4 was a regression, and one was a CFA. Some of the output commands and the save data and the plot commands are here. I went through them very quickly. Just want to make sure that the S values, that I talk about that, it is really useful, and type equals plot1 is extremely useful as well. Let me go through and show you that when I run the CFA. I did. And so as I scroll down, all the way down to the bottom, I have lots of output here, but here are the syntax statements if you wanted to use those syntax to generate simulated data in the Monte Carlo command. So it's already all written out for you. It's extremely useful. So those are model commands with final estimates used as the starting value. So it's really terrific simplification that's provided for you. And one other thing, I'm going to go all the way up here. This is again on the output from running a CFA. I'm going to look into plots. I can either look at there or here. So I'm going to make this selection. And I want to look at histograms. So that'll give me the histograms, the histogram for KFT underscore V1. It's hard to show that with a screencast. It's easier to see it if you saw my entire screen. I can also choose scatter plots, so I could look at the scatter plot of two different variables if I had an interest in that as well. And finally, just whenever you run a CFA, you can go into diagram and you can view the diagram, and that's going to show the latent variable connection with the observed variable diagrams. So that is useful. It does have some options to move things around to make them a little more, convenient for printing if that's what you're looking for. All right, there are a lot of other subcommands and features for output and plot and save data. But I just wanted to go through those very briefly. The last step I want to talk about, actually not the last step, the second to the last step is I want to look at an exploratory factor analysis. So in order to do that, I am going to open up Demo 5, which is called EFA. All right, so there we are. And so this is example 4.1a from the user's guide. The data is simulated data. There are 12 variables, and all I'm saying in this analysis step, there are these two things. One is I'm saying it's a type equals EFA, and I give them two numbers. The first number represents the minimum number of factors to be extracted, and the second number represents the maximum number of factors to be extracted. The default rotation is the oblique rotation of geomin. I'm going to put here oblumin 0.15. I can also include other options such as modification indices, and I can also request plot2, which will give me my scree plot. So with that, I'm just going to now run it. All right, so just to do that first, let's look at the eigenvalues. All right, so there is the plot of the eigenvalues. So I can see 1, 2, 3, 4. It's probably 4 factors is probably what we'll end up using. All right, let me close that. And I'll scroll down. And it provides actually a really nice summary of model fit where you can compare one factor model to 2 factor, 2 to 3, 3 to 4 using a chi-square difference test. And here are other, So here, then the next step you're going to see for every model, it runs the model for 1 factor, gets all the information, and then it runs it for a 2-factor model, and then it does it for a 3-factor model and a 4-factor model. So it's a really good technique for running an exploratory factor analysis. All right, that's all for that. Next, last thing I'm going to do is open up Demo 6, which is an example of the Monte Carlo step. So in the Monte Carlo step, you don't read any data in. You actually just identify that you're going to be simulating 6 variables. You have to tell it how many observations you want in each data set. And then if we were going to be running more than one rep or one example, so each rep is one run of 500, one data set of 500 observations, then I would take that comment off. This provides the seed, and that tells Mplus where to save the data. In my model command, remember I pointed out the syntax that it generated from S values. There it is. There they all are. Those shows how the factors are defined. Those are how the factors are correlated. These are variances and so forth. So that's all there. And I also have a model statement, so that tells Mplus that I also want Mplus to run a model to test to see the fit of this model with the simulated data. All right, so I'm going to go ahead and run this. And I can see a lot of information with respect to how well the simulated data fits the model, and we can go through a lot of that in one of our sessions ahead. But a couple of things that are of interest probably for most people, and that is that most of us have to do some type of power analysis or estimate our type 1 error rate. So if you fix a parameter estimate in the model statement to be 0 when it's not 0 in the population, you can estimate power. If you freely estimate a parameter that was fixed to be 0 in the model population statement, then you can determine your type 1 error. All right. Thank you for listening. I hope you have learned a lot of information about the command statements in Mplus. And next time we meet in workshop 3, we're going to be interested in a destination, and that destination is how to use regressions and how to interpret the results. Thank you.